Hello, hi, a very happy good evening. So this is Krishna Ma'am. We're talking about the story of life on earth, and that's biology. So thank you so much for joining me this evening. So please don't forget to like, share and subscribe. So today we're going to highlight cardiac cycle. So literally the most interesting, the most intricate chapter where we are closely connected with biology is your human physiology. So of the entire 7 human physiology chapter, the chapter that gives us a feeling like a doctor is your body fluids and circulation. So when you look at the structure of the heart, when you talk about the sounds that you hear in the stethoscope, yeah, for a second you have goosebumps on your skin and then you feel like a doctor for a minute. So I hope you're able to relate with me. So when I was in class 12, when I was reading this chapter, I really felt like, yes, I'm a doctor. That's why I'm reading this. So I would say when I started teaching, the only chapter that I didn't read and I just went with the flow because I still remember the concept so well, that would be from this topic. So this is how I read the 4 chambers of the heart. Until today I remember the 4 chambers of the heart like I read it in my class 12. So that is how it happened. So I hope I make today's session interesting. So the most important concept of all, the cardiac cycle. So wherein I will detail about the structure of the heart today. So then I will talk about the cardiac cycle, what is your diastole, systole, and then we'll be moving forward to talk about what is your ECG. So I'll give you a quick introduction and as well as an explanation about your ECG. All right. So and also tomorrow at 5:30, so we will not be having a highlight series. So for all those who are giving your 12th board exam, so your next board exam is biology, so that is on 30th of May. So today I hope you guys have done your physics exam well. So for the next 10 days, so we'll be having one shot revision of the chapters that comes inside your CBSE syllabus. So please cooperate with me. So it's not that if I am taking CBSE classes, the NEET students will not come and listen. Ultimately, I am discussing the same chapters, right? Ultimately, I am discussing the same concepts. So you can join in. So tomorrow, the first chapter that I'll start discussing will be the human health and disease. So you can join with me for human health and disease. So I'll quickly give you a recap of the entire chapter in 1 hour, and probably I will discuss the last 2-3 questions related to CBSE board. So if you want to learn human health and disease, so you're most welcome. For the last 15 minutes where I'll be discussing questions, you can go and continue with your preparation, but in a way I'll be covering these chapters. So once I'm done with these CBSE topics, so then I'll begin my one-shot series for your NEET exam, because 30th May is the end of May, so after which we have only June month, and July 17th you have your NEET exam. So we need to get a pretty bit serious and we need to get hecked up so that our preparation, our schedule works out and you really give your best for your NEET exam, right? So it's not that opportunity is only once, but you can try NEET exam any number of times, but listen guys, you're wasting your time, right? So you should always be hungry for knowledge and wisdom. So studying the same 2 books for more than 3-4 years is going to be really boring at the end of the day, right? So I guess you should all move forward. So it's not that you can, some students I've heard them say, okay, if I don't clear NEET this year, I will take a drop. So that's not the case. So the more, life is very short, right, at the end of the day. So make sure you grasp as much as you can in the limited time, in the limited tenure that you're alive on Mother Earth. So don't be in this attitude that yes, I can take a year drop. So taking a year drop is a next case wherein you die-hardly wanted to prepare and you couldn't do it and you take a drop. But just like that, don't go with that attitude. That is not best, because you still have a lot to learn. So what if you say 1 year? So that's not going to affect you in any ways, right? So all right, let's move further with your cardiac cycle. So this is a very interesting topic. So you can say one of my most favorite topics. Okay, so this is, just give me a second. This is probably not working. Okay, so let's leave this. Yeah, so let's move. So what I have to tell you today, so we are talking about the circulatory system, right? Yes, ma'am, a very happy good evening. So thank you so much for joining my session. So please do like, share and subscribe. So when I talk about body fluids and circulation, so in this chapter, if you have seen this chapter, if you've read this chapter, if you've seen my previous lectures in this chapter, so we basically highlight the importance of circulation. Why should there be a circulatory system? So for example, someone has to carry oxygen, someone has to carry out the waste carbon dioxide, someone has to carry the hormones from the pituitary to the target organs. So for all that, we need a common passage, we need a common pathway, and that is your circulation, right? So for example, if I want to go go from here to Gujarat. So I would not be actually willing, or I cannot afford to spend my own money to build a flight or a train or a bus for myself, right? So I would look for the local trains that are available. I would open IRCTC and look for the trains, right? So a common circulation is like a public transport system that is running in the country, right? So who are the members of this circulatory system? So when I say the term system, so it includes 2 or more members, right? So who comprises of these systems? So first of all, you have a blood vascular system. So vascular means the passage of moving in and out of blood, okay? So you have a heart, a muscular chambered heart, which is of your mesodermal origin. So mesoderm, it's one of the embryonic germ layer. You have a network of close branching blood vessels, because I hope you remember, so we have open circulatory system as well as closed circulatory system. So followed by this blood vessels, we are ultimately going to talk about blood, which is the fluid that is circulated. So who are the members of your circulatory system? First of all, it is your muscular chambered heart, you have your blood vessels and your blood. So now coming to the point of what is open circulatory system, what is closed circulatory system. So open circulatory system is wherein the blood vessels are not well developed, whereas closed circulatory system, the blood vessels are properly developed. So in open circulatory system, the organs are bathed inside a particular cavity, that is hemocoel, and the blood flows in and all the organs immerse themselves inside the cavity and blood flows back to the heart. Whereas in closed circulatory system, each particular organ has a vein that comes out of the heart and goes back to the heart. For example, let's take lungs. You have the pulmonary vein and the pulmonary artery. When you talk about the liver, you have the hepatic vein and the hepatic artery. When you talk about the kidney, you have the renal vein and the renal artery, right? So you have a particular direct connection with the heart. All right. So these are the members of your heart. So heart is mesodermally derived organ and it is situated in the thoracic cavity. So it is in the front, right? So I hope you know what is your thoracic cavity, the one which is supported by a thoracic vertebrae, right? So in between the 2 lungs it is present and it is slightly tilted towards the left. So this is the structure of your heart. So to look at it, this structure looks a bit complex, but what we usually do is I teach you in my own method the structure of the heart. So that is how it usually happens. So let's see if I can teach you the structure of the heart myself today. Yeah. So a quick introduction into how the chambers of the heart are divided, what are the valves, and how the flow circulation or the flow starts, and then we'll move into the cardiac cycle. All right? Yes. So here we go. Okay. So I hope all of you know the heart has 4 chambers. The heart is 4-chambered and it has a double membrane. So the membrane of the heart is called as the pericardial membrane. So the membrane of the lungs is your pleural membrane, sorry. So don't get confused between pleural and your pericardial membrane. So during the structure of the heart for you, so you have 4 chambers. So what are the 4 chambers? Is out of this 4 chambers, you have 2 chambers that is called as the atria. So atria is plural. When I say atrium, atrium is singular. Then I have 2 ventricles. So this 2 is right and left, okay? So this is the right hand side, this is the left hand side. So this is my right atria, this is my right ventricle. Right? So this is my left atria, this is my left ventricle. So these are the 4 chambers. The heart is surrounded by a double membrane fluid, that is the pericardial membrane, and the space in between the outer and the inner pericardial membrane is filled with your pericardial fluid, right? So I am talking about this. So this is your pericardial membrane. So I can directly draw the arrow. I am not writing it once again. Right? Okay. So in between the 2 atria, I have a septum. That is, I have a wall. I have a division. So this division is called as the interatrial septum. Okay. So in between the 2 ventricles, I have a septum, but this septum is pretty thick. and the name of this septum is interventricular septum. This is thick. In between the atria and the ventricle also you have a septum which is neither thick or very thin. So this is called as the atrioventricular septum. Fine? Yes? Okay. So in between the chambers you have what is called as a valve. So you have a valve here, you have a valve here, you have a valve here, you have a valve here. Valve is what prevents the backflow of blood. So the valve that is on this side is called as the tricuspid valve. The valve that is on this side is the bicuspid or the mitral valve. Okay, so the valve here at the end of the ventricles, both right and left, so these valves are known as the semilunar valves. They are two different valves, but both the valves have the same name. The name of these valves are the semilunar valves. Clear the structure? This much is clear? Alright, so now something brings blood inside the right ventricle. From the right atria, it moves into the right ventricle. So from the right ventricle, it comes out, and somewhere it is coming inside the left atrium into the left ventricle, and it moves out. So from where to where the blood is coming, so that is what we are going to see next. So your right side has only deoxygenated blood. Your left side has your oxygenated blood. Okay. So who brings in your deoxygenated blood into the right ventricle is your superior or your inferior vena cava. So you have your superior or your inferior vena cava. So they bring deoxygenated blood into the right atrium. Your superior vena cava brings the deoxygenated blood from the upper part of the body, that is from your brain and your neck. Your inferior vena cava brings your deoxygenated blood from the lower parts of your body. Fine? So they bring it into the right atrium. So once the blood is maximum inside the right atrium, the tricuspid valve opens and it flows into the right ventricle. What? The blood flows inside the right ventricle. Once the right ventricle is filled up, it is so stressed, it is pressurized, so the semilunar valves open and the blood flows inside what is called as the pulmonary artery. So pulmonary artery carries the blood into the lungs. Hi Rose, yes, a very happy good evening. Thank you so much for joining my lecture. So please do like, share and subscribe. So a pulmonary artery carries the blood into the lungs. So the entire side of right atria, right ventricle, pulmonary artery has your deoxygenated blood. So from the lungs you have what is called as the pulmonary vein. So when the blood is coming out of your lungs, it is oxygenated. So this is deoxygenated and this is oxygenated. So this pulmonary vein takes the blood into the left atrium. When the left atrium is packed up, the bicuspid or the mitral valve opens and the blood flows inside the left ventricle. Okay. When the left ventricle is full, it's pressurized, it has maximum blood, so it opens the semilunar valve and the blood flows inside the aorta. So aorta takes the blood to the body parts. Alright? Yes? So this is the entire circulation. But there's a small twist here. So when I happily said blood from the inferior or inferior vena cava moves into the right atrium, then the tricuspid valve opens, it moves into the right ventricle, then the semilunar valve opens, it moves into the pulmonary artery, it goes to the lungs, and the pulmonary vein moves into the left atria, then the bicuspid valve opens, it moves into the left ventricle, then the semilunar valves open and it goes to the aorta. So I said it easily, but it does not work this way. Rather, your right and the left side both work simultaneously. When blood flows inside the right atrium, blood also flows inside the left atrium. So when the blood from the superior and inferior vena cava comes inside the right atrium, blood from the pulmonary vein comes inside the left atrium. And when the tricuspid valves open, the bicuspid valve will also open. When the blood enters the right ventricle, so will the blood enter the left ventricle, and both the semilunar valves will open together and blood will simultaneously move into the pulmonary artery and into the aorta. Done? So the the structure of the heart is understood. Which valves you have, what is the path of circulation. So this much is clear. Yes, any doubts so far? So this much you understood, the 4 chambers of the heart. So what are the valves, from where to where the blood comes and where to where it flows? The simplest of concept. Yes, did you understand? Is this way easy rather than drawing the entire structure of the heart to explain? So this is how I read when I was in class 12, and trust me, even today I remember it, right? Okay, so we go to the next part. Okay. The heart is mesodermally derived organ. So if you remember human reproduction, so we have a stage called gastrulation, where you have 3 embryonic germ layers, ectoderm, endoderm and mesoderm, right? So they are derived from the mesoderm. Your heart is derived from the mesoderm, and it is situated in the thoracic cavity between the lungs. So we've already seen this. So it is protected by a double-walled membrane that is called as the pericardium. So it encloses the pericardial fluid. So there are 4 chambers, 2 chambers on the upper side is atria, and the 2 chambers on the lower side are your ventricles. So you have a thin septum between the right and the left atria, you have a thick septum between the right and the left ventricles. Atria and the ventricles are separated by the atrioventricular septum, right? Yeah. So you have something called as the nodal tissues of the heart. So your heart is auto-excitable. So you and I does not say, okay heart, come on, now you have to beat. So we don't do that, right? So do you do? No. So heart is under the involuntary control, right? So your heart knows when to pump, and it's understood that your heart should not stop pumping of blood, right? Yes? Okay. So Pranav, hi. So I am from which state? So is that question going to come in NEET exam? Anyways, Pranav, welcome to my session. So please do like, share and subscribe. Thank you so much for joining my session. Okay, so your heart is under the involuntary control. So how does your heart knows when to initiate the pumping? So your heart is autogenic or myogenic in nature, meaning it can stimulate the contraction on its own. So which part, who inside the heart stimulates this? So that is what we are going to see. So this is the structure of the heart, I don't deny, but for our understanding, we'll draw it our way, okay? Okay. So we'll draw it our way. Right? So towards the right atrium, the upper part of the right atrium, I have a small patch of nodal tissue. Nodal tissue means a patch of tissue. So the name of this tissue is called as the SA node. SA stands for sinoatrial node. Okay. So this is what actually begins the stimulation. So this is what knows, or this is what is myogenic, or this is what is automatic, which initiates the impulse or the contraction of your heart. So this tissue is known as the natural pacemaker of your heart. So when this does not function, people go for artificial pacemaker, which is made up of some metals like lithium, etc. So right after this SA node begins the stimulation. So in this junction, you have what is known as between the atrioventricular septum, you have another patch that is called as the AV node. So AV node is at the junction between the atria and the ventricle, that is in the atrioventricular septum. Okay, so AV node atrioventricular node. So from your SA node, it passes into your AV node. Then from there, you have what is called as bundle of His. Bundle of His is present in the interventricular septum. Okay. So from the AV node, the stimulation comes to your bundle of His. So from the bundle of His, I have a network of fibers which carries the impulse throughout the ventricles. These network of fibers are called as your Purkinje fibers. So who actually begins the stimulation? So you have your SA node, AV node, then you have your bundle of His, then you have your Purkinje fibers. So this is how stimulation inside your heart flows. Clear? Yes? Any doubts further? Can I continue? Yes? Alright, so let's move forward. So now the next concept that comes under this topic is the cardiac cycle. So what is this cardiac cycle? So let's see what it is. Yeah, so this is a very common diagram that you see in my slides when I talk about cardiac cycle. So I told you who initiates the signaling, the SA node. It is copied by, the signal is passed on by the AV node, bundle of His and the Purkinje fibers. But what exactly happens? We do not know. So that's what we are going to see. So when you talk about the cardiac cycle, that is the pumping of the blood inside the heart, what happens is you have to remember two terms. The two terms are systole and diastole. So diastole, systole. So what is systole? Systole is the contraction phase. Diastole is the relaxation phase. Fine? Okay. So now what happens? Initially, all the four chambers of the heart are in a state of rest. That means they are in a state of relaxation. So this is called as joint diastole. After they are in a state of rest, blood slowly starts moving into the right and the left ventricles. First they are in the state of rest. Yes, after they are in the state of rest, the blood slowly moves into the right atria and the left atria from the superior inferior vena cava and the pulmonary vein respectively. Okay, so when blood moves inside the atria becomes more pressurized, right? So this causes the opening of the tricuspid and the bicuspid valve. So when the tricuspid and the bicuspid valves open, so that is when you get the first sound, 𝐿𝐵. So in stethoscope, you listen to two sounds, one is 𝐿𝐵, one is 𝐷𝐵. The 𝐿𝐵 sound is because so listen. So you have joint diastole, then blood moves into the atria. So when the tricuspid and the bicuspid valves open, so that is when your atria is contracting. So this is atrial systole. So now the blood moves into the ventricles. When it moves inside the ventricles, the tri and the bicuspid valves close. When the tricuspid and the bicuspid valves close, that is when you get the first sound, that is your 𝐿𝐵. Okay. So now the blood moves inside the ventricle becomes pressurized, the ventricle has more amount of blood, so your semilunar valves open. So when your semilunar valves open, so that is when your ventricles are contracting. So this is called as ventricular systole. So when the ventricle contracts, simultaneously your atria is resting. That is atrial diastole. So now when your semilunar valves close, that is your second sound, that is your dub that you listen in your stethoscope. So what is your cardiac cycle? A series of diastole and systole is your cardiac cycle. Alright? Yes? Okay. So first of all the four chambers are in rest. So that is your joint diastole. Then your tricuspid and your bicuspid valves open, and that is when your atria is contracting, that is your atrial diastole. So then your tricuspid and your bicuspid valves close, that is when you listen to the first sound in the stethoscope, that is your love. And then when the ventricles contract, the semilunar valves open, so that is your ventricle systole and atrial diastole. And when the semilunar valves close, that is when you listen to the second sound. Alright? Yeah. The sequential event in the heart, which is cyclically repeated, is your cardiac cycle. This consists, it consists of systole and diastole. The heart beats 72 beats per minute. So these days you have smartwatch, right? So for example, probably the other day I wore the smartwatch, so it actually measures what is my average heartbeat rate. So here it says 72 times per minute, so that day the watch showed around 78. So it can vary from person to person. This is on an average. The duration of each cycle is 0.8 seconds. So one systole and diastole takes 0.8 seconds. So each ventricle pumps approximately 70 ml of blood. Hi friends, hello, yes, a very happy good evening. So after a very long time you're here, and I'm so glad you remember me. Thank you once again. So please don't forget to like, share and subscribe. Alright, so you have your right ventricle and your left ventricle pumping blood. So the right ventricle pumps blood into the pulmonary artery, and your your left ventricle pumps blood into your aorta, right? So these two ventricles approximately pump 70 ml of blood, and this volume of blood it pumps is called as the stroke volume. Alright. So stroke volume into the heart rate is equal to the cardiac output. Ronak Chauhan, yes, good evening. So thank you so much for joining my session. So please do like, share and subscribe. So we have the stroke volume with us, that is 70 ml. I told you what is the heartbeat, that is 72 beats per minute. So this into this will give you the cardiac output. So your cardiac output is 5000 or 5 ml in a healthy individual, right? Yes? You never reply on Telegram. Why? I guess I replied to you, Raj. So recently did you send me any message? Because I remember replying to all the Telegram chat day before yesterday. So if your message was very old, yes, I did reply. So I think you have to go and check. Yes. Ma'am, please tell the schedule of the NEET MCQ series. So I am not doing MCQ series. Okay, so today I am doing highlight series. So tomorrow I am doing quick revision for CBSE term 2, because they have that biology paper on 30th May. So in a way, I'll revise all the 6 chapters that is there for your CBSE board. I will revise from the NEET point of view as well. So tomorrow I am discussing the chapter Human Health and Disease. So it's my request that all of you come, because that's a very important chapter, right? So yeah, this is your cardiac output. So let's see what question I have. So what would be the heart rate of a person if the cardiac output is 5 ml? Blood volume in the ventricles at the end of diastole is 100, and at the end of ventricular systole is 50. So you have the options here. So which is the right one? Acha, you have the paper on 30th. Okay, so tomorrow I am starting. So I will do all the 6 chapters quick revision. I will discuss the questions also. And last one day, that is on 28th, I will discuss the sample paper. So tomorrow I will be starting with your human health and disease. Okay, Ronak? Yeah. So how do we solve this question? So the cardiac output is given. So let me write the formula. So cardiac output is equal to your stroke volume into your heartbeat. right? So here we are supposed to find the heartbeat, so this is X. So what is the stroke volume here? So stroke volume is not directly mentioned, so cardiac output is 5 liters, or this I can rewrite it as 5000 ml, right? So this value is not very clear cut. So they are saying diastole is 100, systole is 50. So how do you find the stroke volume? Is the diastole minus systole, that is 50 ml. So this is 50. So now X is equal to 5000 ml by 50. So this is 100 beats per minute. So this is a hypothetical question. You can ask me, ma'am, how can a person have 100 beats, right? So yeah, that's not possible, but this is a hypothetical question. Alright, yes? Yeah, so our answer is right. So we move forward. So I guess okay, so now we're going to talk about ECG. So Prince says, ma'am, I request you to start a batch in Hindi and English. Oh my God, so do you really find my English tough? Huh? Why can't you learn English? So should I slow down? The reason I'm not doing Hindi-English batch is you already have another channel of 𝐒𝐴𝐴𝐴𝐴𝐴𝐿, which is completely in Hindi medium. So you have people, you have faculties, you have a team which is working on your Hindi mixed language. So that is the reason I don't involve there, and this is my platform. So I would like to communicate in English. So yeah, if you want me to slow down, if you want me to help you out in any other way, yes, I can. But for you, if you want to have it in mixed language, you have another channel, that is 𝐒𝐴𝐴𝐴𝐴𝐴. So you can also refer to that channel. All right. Yeah. So what is ECG? ECG stands for electrocardiograph. Okay. So it is a graphical representation of electrical activity of the heart during the cardiac cycle. So my heart does diastole and systole. How do I know my heart is doing diastole and systole right? For example, when a person has BP, people do this ECG to check if their diastole and systole are in balance, right? So how do they do? This is how they do. If you have seen, they connect the person's chest with a series of electrodes, and the result you can see it in the graph here, right? So what is the result that they see? So the graph looks something like this. So every person, the length of this P peak should be this much, and the length of R peak should be this much, and the T peak should be this much. If for anyone the peak is abnormal, then the diastole and systole, the cardiac output, has a problem. Okay. So what does the P represent? So P represents atrial systole, or you can say atrial depolarization. Polarization is in the resting condition. So depolarization is the relaxing condition. So QRS represents ventricular systole or ventricular depolarization. This represents your ventricular diastole, that is when your ventricle is resting. This is resting after contraction. Initially when they are in rest, that is polarization. When they contract, it is depolarization. After contraction, when they go to rest, it is called as repolarization. Ventricular repolarization. So this is your ECG, and for sure you always have a question in ECG, right? So with this we come to the end of cardiac cycle, which has been highlighted. So tomorrow I am teaching for board, so it's a quick revision for all the 6 chapters for the board exam, that is on 30th May. So we stop here. And before that, for all those who are preparing for NEET, so I would like to mention CareerPoint has so many books from its own publication. So I would request you to pick any book, solve the questions, and if you have any doubts, to discuss with me. If you genuinely find the hard copy pretty high budget, so you can go in for Google Books. So you get the books in 2-digit numbers. So I guess that is affordable. So please do go. And you have this NEET revision test series. Again and again I'm telling you. So yesterday also I got a student's call saying, ma'am, how do I solve the questions? So should I appear for NEET 3-hour test and see where I stand? Answer is definitely yes. Only when you sit for 3 hours, look in the physics, chemistry and bio paper, you know how you're going to manage time. So that is when you will know the apt importance of time management. So please purchase this test series so you have at least 1 month solid. So if you solve one question paper every 2 days, so that would do a great difference in your time management. So if you're one of the 100 enrollments to get this 25 NEET revision test series, you get the 60 days NEET crash course for 499, which is otherwise 1999. So you get an offer, so it is a double dhamaka offer. But if you feel, no, I don't want this, I will learn from you, fine, but you can go for the test series, right? And for all those who are willing to join or who have decided to take up NEET or JEE, so here your classes begin on 11th June. And if you say you have financing problems, my parents cannot pay my school fees, that itself is high, so I don't think if they allow me for coaching, relax. So you can give the scholarship exam. So you have previous year scholarship papers, you can go through them. So you can give this test and you can get or avail scholarships that is available. Alright, so thank you for giving your valuable time to me. So if you genuinely like my session, so please do like, share and subscribe. So thank you so much once again for staying with me this evening, and tomorrow at 5:30 p.m. I'll start with human health and disease. So until then, stay tuned and take care. Thank you.